Good evening, everyone. My name is Nora Hadina binti Faizal, and I am excited to guide you through a fascinating topic that I've learned, which is intermolecular force, which I like to call it as the invisible glue because of how they shape our world. Today, we explore how the subtle forces affect everyday observation like evaporation rates, viscosity of liquids, and solubility, and even the texture of the plastic around us. By the end of this presentation, you have a new appreciation for the glue that holds chemistry together and explains countless daily phenomena. So, what are intermolecular force? Before we dive into properties, we need to understand what are intermolecular force, or the short name for it, IMFS. In high school chemistry, we spend a lot of time on the strong intramolecular bonds within a single molecule, which are covalent bond and ionic bond that holds the atom together. IMFs, however, are the attraction force between separate molecules. Think them as a glue that holds the molecule to stick to each other. They are significantly weaker than those intramolecular bonds, typically 25 to 100 times weaker. Is this relatively weak force that determines a substance physical state, whether it is solid, liquid, or gas? There are three main types that you need to know. The first one is London dispersion force, second one is dipole-dipole force, the third one is the hydrogen bonding. The strongest one present dictates most of a substance behavior. All right. The first type and the weakest of the three major IMFs are London dispersion force. These forces are temporarily attraction caused by a constant random movement of electrons. At any instant, more electrons might cluster on one side of a molecule, creating a temporary instantaneous negative pole and a positive pole on the other side. This temporary dipole can then induce a similar dipole in a neighboring molecule, creating a weak fleeting attraction. Lambda dispersion forces are present in all molecules, polar or nonpolar, and are the only force of attraction for nonpolar substance. Their strength increases with molecular size and mass because larger molecules have more electrons that can fluctuate, making them easier to polarize.
Assalamualaikum everyone, and hi, I am Shazoni Alia, and today I'm going to present to you about dipole-dipole forces when polarity matters. Dipole-dipole forces happen in one polar molecules that have permanent positive and negative end. In these molecules, the positive end of one molecule is attracted to negative end of another nearby molecules. This attraction causes the molecules to align in a specific way, positive to negative. Compared to London dispersion force, dipole-dipole forces are stronger for molecules of similar size. An example of these forces can be seen in hydrogen chloride, which is HCl. In this slide, I'm going to talking about hydrogen bonding. Hydrogen bonding is the strongest type of intermolecular forces. It happens when hydrogen is bonded to very electronegative atoms, such as nitrogen, oxygen, or fluorine. In water molecules, the hydrogen atom of one molecule is attracted to oxygen atom of another molecules. This attraction is shown by the dashed line in the diagram. Hydrogen bonding is very important because it gives water its special properties and also helps stabilize biological molecules like DNA. For this slide, I'm going to summarize the strength of intermolecular forces. For LDF, which is London dispersion force, are the weakest and are found in all molecules. Dipole-dipole forces are the stronger one and occur in polar molecules. And the last one is hydrogen bonding, is the strongest intermolecular force. The strongest the forces present effect physical properties such as boiling point, For this slide, I'm going to summarize the strength of intermolecular forces. London dispersion forces, which is what we call it LDF, are the weakest and are found in all molecules. Assalamualaikum. Ya, cannot lagi. Assalamualaikum. For this slide, I'm going to summarize the strength of intermolecular forces. For LDF, which is we call it as London dispersion forces, are the weakest and are found in all molecules. Dipole-dipole forces are the stronger one and occur in polar molecules. And the last one is hydrogen bonding. It's the strongest intermolecular forces. The strongest force present the physical properties such as boiling point. For example, methane has only London dispersion force, HCl has only dipole-dipole forces, and water has hydrogen bonding.
Assalamualaikum and hi everyone. So in this slide, I will talk about melting point and boiling point. So what is this attraction between intermolecular forces? So in this slide, I will explain one by one. So first and foremost, I want to give some exciting analogy about molecules. Molecules is like people holding their hand. So when people holding their hand tightly, you need more energy to pull them apart. So it is a same concept like hydrogen bonding. So do you know that intermolecular forces have two types of forces? First is stronger forces and second is a weak forces. We know that strong force is hydrogen bonding and weak forces is London dispersion forces. So when we talk about hydrogen bonding, we know that it is attract with water molecules, right? H2O, because H2O molecules is held by hydrogen bonding. So that's why everyone know that when we want to boil a water, we need 100 degrees Celsius to boil that so we can drink the water. As we can see in this slide, there is two molecules that I put in the graph like methane and methana, CH4 and ammonia and H3 is types of London dispersion forces. So London dispersion forces is a weak forces, means it need less energy to pull them apart. London dispersion forces occurs when electrons move and create temporary dipole. So I think that's all for this slide. So in this slide, I will talk about water again. And do you know that people always ask, why water have to boil at 100 degrees Celsius? Why not less than that? So we know that water plays a vital role in our life and it have a physical properties like higher melting and boiling point that I have mentioned before this. So water is like magnets that pull them together. So that's why we need more energy to pull them apart. Water molecules form hydrogen bond, which it is a type of strong forces, and they need enough energy to escape into gases. So let's take a look at this last slide that I will explain to you guys about evaporation. So evaporation is when surface of molecules gain enough energy to form into gas. So this evaporation process is called in Malay as penyejatan, is affected by strength of forces. If the forces is strong, so the rate of evaporation process it will be slower than weak forces. Yes, of course, because stronger forces need more energy and it is slower than weak forces. So I can conclude that weak forces have faster evaporation. So that's all from me. Thank you.
Assalamualaikum and hi. So I will talk about impact on viscosity. So viscosity means how thick or runny a liquid is. For example, honey is thick and flows slowly, while water flows easily. So what happens between them? This happens because of intermolecular forces. When these forces are strong, the molecules stick together tightly, so the liquid flows slowly. Therefore, stronger intermolecular forces give higher viscosity. So, got it? So next, I will talk about impact on solubility. Solubility is how well one substance dissolves in another. The rule like dissolve like means polar substance dissolve in polar solvent and non-polar substance dissolve in non-polar solvent. So, for example, salt dissolve in water because both are polar. But oil and water do not mix because oil is non-polar and water is polar. Intermolecular forces determine whether new attractions can form between substances, allowing them to mix. Let's move to another part, which is impact on polymer taste. Intermolecular forces also affect the texture of polymers. Polymers are long chains of molecules. When the intermolecular forces between chains are weak, the chains can move easily, making the material soft and flexible, like plastic bag and rubber bands. When the forces are strong or the chains are cross-linked, the material becomes rigid and strong, like PVC pipes or Lego bricks. So the next slide is real-world applications. This slide shows how intermolecular forces are used in real life. First, in medicine, intermolecular forces affect how drugs dissolve in the body. If a drug dissolves well, it absorbs faster and more effectively. This is why solubility is very important in pharmaceutical products. Next, in industry, intermolecular forces help scientists choose the correct solvent. For example, polar solvents are used to dissolve polar substance, and non-polar solvents are used for non-polar substance. This is important in processes like cleaning, painting, and manufacturing. Finally, in everyday life, intermolecular forces explains simple things such as why some liquids mix, why others do not, and how liquids evaporate. So intermolecular forces not just
To summarize on what we've covered today, the invisible glue of chemistry comes in three main types: the universal London dispersion force, the permanent dipole-dipole force in polar molecule, and the exceptionally strong hydrogen bond. The key takeaway is simple: stronger IMFs requires more energy to overcome. This means substances with strong IMFs have higher boiling point, are more viscous, and evaporates slower. These fundamental forces are why water is liquid and not gas, why honey is thick, and why oil and water don't mix. They truly explain countless daily phenomena. Looks like we've reached the end of our presentation. Thank you all for your attention today. I hope this presentation has shed some light on how this crucial force operate in our world. Thank you.